Hello, this is Mr. Waters, and we're continuing here on this video with what we were doing on the previous video, and that is working with series. And in the previous one, where we ended up was we were working on writing out series, and you were given the series in sigma form, like this one right here. Okay, and then you wrote it in expanded form like this. Now what we want to do here is we're going to work the problem the other way around. We're going to be given the series in expanded form and write it in, well actually let me write that out there, in expanded form, and we're going to write it in sigma notation. Okay, now that's going to involve looking at the expanded form and trying to deduce kind of what the pattern is or what the formula is. So in other words, you're gonna start with this, you understand, right? And we're gonna end up with that. That's the plan. So let's start with a relatively simple one. So here it's expanded form. Say 1 plus 2 plus 3 plus dot 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 up to say 15. Okay, so you're thinking about that one. Okay, so what we want to do is we want to have a formula, kind of like this one here, that will generate the terms of that sequence, or generate the terms of that series. Okay, so in order to get that, let's kind of note what the term numbers are. Keep in mind, this is the first term, this is the second term, this is the third term, and we keep going, right? Boom, boom, boom. And so maybe you can see that up here, that would have to be the 15th term. So maybe you can see that really each term in the series is just also the same as the term number. So that gives us and we're just adding up those term numbers. So this gives us the relatively simple series like this. Sigma, just like that, 1 up to 15. We write 15 on the top because we can see from our pattern we're going to the 15th term, and I'm just going to put n. Okay, so this goes from 1 to 15 with n the first, so the first term would be 1, the second term would be 2, the third term would be 3, and dot 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 all the way up to, if we wanted to, up to the 15th term. So we see that that generates that back again. Okay, so this is right here is the answer that we are seeking. That is this series here written in sigma notation. Now let's try another one. I'm going to pick one that I'm going to see like from your book. Okay, so how about this? 1 over 2 plus 2 over 3 plus 3 over 4 plus 4 over 5 plus dot 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 up to, let's say 19 over 20. Now what we want to do there is we want to see what's the pattern. So I'm going to go ahead and write the term numbers up above. This is the first term, this is the second term, this is the third term, this is the fourth term, and dot dot dot. This is the nth term, but we don't know necessarily what it is right now. What we're looking for is a formula, something like that simple one right there, that if we substitute n in, will generate, if we substitute n equals 1, n equals 1n will give us this, that if we substitute n equals 2n will give us this, n equals 3n will be equal to this, n equals 4n and will give us this, and so on all the way up to whatever this n number is up here. Well, maybe you can see in our pattern that I've written out that the top number in each fraction is the n number. So that's n is 1, that's n is 2, n is 3, n is 4. So maybe you can see that the bottom number is n plus 1. This bottom number is 1 plus 1. This bottom number is 2 plus 1. This bottom number is 3 plus 1, 4 plus 1. Okay, so this, in other words, if this is n up above, down below is going to be n plus 1. So that gives us a clue out here. Oh, 19 has to be n, and so 20 is n plus 1. So that means that this is the 19th term. We're counting out to n equals 19. And so that's going to tell us in sigma notation, it's going to look like this. Our formula is going to be n over n plus 1. And we're going to count from 1 up to 19. If we'd started out with this sigma notation here, n would be 1, and that would give us 1/2. Then we do n as 2, and that would give us 2/3. Then we do n as 3, and that would give us 3/4, and so on, until n is equal to 19 would give us the last term in our series, 19 over 20. Anyway, so that is what we are going to do with that. That's how you go about taking a series written in expanded form and putting it in sigma notation, and there is the answer there that we would write down for our second problem. Anyway, thanks for listening.